So our goal for today is to learn how to factor any type of trinomial. So we're going to look at more complicated trinomials in which the a values are greater than 1. So the a values up to this point have all been 1, meaning that they were easy. You could simply just factor them as they were. Now we have the extended idea of the magic X and factoring for a little bit more complicated situation. So let's look at that type now. So one of the things that's important or helpful is to always look at or look for a GCF. So in this example here, you have 20x squared minus 24xy. So 20 and 24 both divide by 4. So we're going to take out a GCF of 4. Both x squared and x contain x's, so we're going to take out an x. And that leaves behind 5x minus 6y. You should be able to distribute your GCF back in and get what you started with. And then what we're eventually going to do is look at how we can take out a GCF and then factor even further. So in this example, we notice that each term is divisible by 4, and each term contains a y squared. So we're going to take out a 4y squared, leaving behind 4x minus 6z plus 10. Yes. What? Oh, take out an 8, yes. So sometimes, and that was part of the process, is sometimes you don't take out the full GCF. So Cole said, hey, why don't we just take out an 8? So sometimes you might take out a GCF that's not your largest, and then you recognize that once you get to your next line, and you can say, all right, instead of taking out a 4, or I could at this point take out a 2, making this 8y squared, 2x minus 3z plus 5. So as we simplify and work through these problems, we're going to see that maybe not every time we take out the full GCF, but we recognize it later. We also might start to factor a problem and recognize a GCF. So the GCF is the first thing we learn, and it's one of those concepts that if you can apply it, it makes your life a little bit easier for these types of more complicated problems. X squared minus y squared was our difference of squares. So that was one of our special formulas. It always factors as x minus y, x plus y. So again, x squared minus y squared factors as x minus y, x plus y. And then here we have 18c squared plus 8d squared. Now, this is a case where you have a sum of squares. So 9 and 4 are perfect squares, c squared and d squared are perfect squares, but we are adding them together. Added sums of squares do not factor like a difference of squares. If that was a minus, we could simplify this, but because that's a plus sign, we cannot. Okay? And then we have 4m squared minus 64. So that's the same because the commutative property of addition says we can rewrite. Then we notice that these are a difference of squares. So you get 2m minus 8, 2m plus 8. Now, I've been working with you guys and looking at the magic X. You could actually do a magic X for this. Your last term would be 64 times 4, and your middle term would be 0. So you would have to multiply your 4 by 64 so that you had 256, and then it would be the factors of 266 to sum to 0. But because we have that front term, that leads us into what we're going to look at today. So yesterday we warmed up with FOIL. We're going to also warm up with FOIL today. So we have 2y times y, which is 2y squared, 2y times 6, which is 6y, 2y times 2, and 2 times 6. Combining like terms, you get 2y squared plus 14y plus 12. So the other day I got asked, what's an easier way to help pick factors? So when you're having trouble picking your factors for the magic X, sometimes it's helpful to actually use the first term and the last term, and then you can divide those numbers and multiply the other side. So I'm going to show you an example of how you can use your first and last term that you're given to help you find other terms as well. Okay, so give me 1 second to pull up the notes. And let's work through some of these more complicated magic X problems together. So we have 3x squared plus 11x plus 6. So now when you do your magic X, you have 3 times 6, which is 18. And then we have 11. So I need factors of 18 that sum to 11. Since it's positive, positive, both my factors are positive. So that will be 9 and 2. So what I'm going to do is now 9 and 2 aren't my last two terms because I have an a value. So instead, 9 and 2 are going to replace 11. So we're going to say 3x squared plus 9x plus 2x plus 6. So you replace the middle term with the factors that work. And now, this is just like the problems we did on Tuesday, which is factor by grouping. So we're going to use factor by grouping. So you group the first two, you group the last two. You take out a 3x, and you're left with x plus 3. Take out a 2, and you're left with x plus 3. So 3x squared plus 11x plus 6 factors as 3x plus 2 and x plus 3. So it's just like our factor by grouping, but now we have to create that one extra step, and that extra step we're creating is actually the line you get from FOIL. So first, outer, inner, and last. So it's almost like reverse FOIL using this magic X concept. It works for all quadratics that need factored. Okay, and then we have 4x squared plus 16x plus 7. So again, you're going to multiply the first and the last. And you want to find factors of 28 that sum to 16. So you need two numbers that multiply to 28 and add to 16. So that's 14 and 2. You're going to replace 16 with 14 and 2. The order you replace them does not matter because addition is commutative. So you could have done 4x squared plus 2x plus 14x plus 7. You would still work out to the same two factor by grouping simplifications. So in the first two terms, we're going to take out a 2x, leaving 2x plus 7. And in the second equation, our GCF is a 1, leaving 2x plus 7. So this factors as 2x plus 7, 2x plus 1. And again, you can always reverse FOIL and check yourself. Okay, so we have 5x squared minus 13x plus 8. So this is an example of yesterday, like case 2, where you have a positive at the end and a negative in the middle. So that gives 5 times 8, which is 40, and then negative 13. So now, because the middle term is negative and the last term is positive, both of my factors need to be negative. So negative 5 and negative 8 sum to negative 13 and multiply to positive 40. So that's where I was saying that sometimes the actual numbers in your problem end up being the numbers in your factoring terms. So now what we're going to do is replace negative 13 with negative 5 and 8. But just like the other day with factor by grouping, you have to be careful about where you group your parentheses. Oops. So what I mean by that is that I have to make sure when I group my last two terms together, I put the negative inside my factor by grouping. So it's kind of like a plus a negative if that helps you with your factor by grouping. But you always want to make sure that if your factor is negative, you group it in the parentheses. So we take out a 5x from the first two terms. And then we take out a negative 8 from the second two terms, leaving me with x minus 1. So that means my factors are 5x minus 8 and x minus 1. So hopefully you notice that even though we're using the magic x like we did yesterday, the values at the end of the magic x are not like the values yesterday. Where yesterday these two numbers here were my last two numbers in my factoring. The same is not true for today. So I just want you to recognize that if there is an a value, these numbers do not replace the last numbers. And that is the new part of today's lesson. Okay, and then our last example type. So this example is 3x squared minus 4x minus 4. So now I have a negative here and here. So two negatives means that one of my factors is positive and one of my factors is negative. 3 times 4 is negative 12 and negative 4. So since my bottom term's negative, it means my larger factor is negative. So I need two numbers that multiply to negative 12, but add to negative 4. So that's going to be negative 6 and positive 2. if you have a single negative factor, I always write my negative factor first. So I'm going to write negative 6x plus 2x minus 4. So if I only have one negative factor in my magic x, I always write it first, because then I don't have to worry about grouping in my negative. So I take out a 3x, and that last leaves behind x minus 2. And then I'm going to take out a 2, also leaving behind x minus 2. So I have 3x plus 2, x minus 2 as my factors. Okay, so then I want you to take a minute and try those last 4 on your own, and then we're going to reconvene in about 4 minutes to go over them. So take about 4 minutes and try those last 4 on your own as part of the lesson check, and then we're going to come back together and do them as a group. Like a majority of us are finishing up, and then we'll go over these and make sure that we are all set. Okay, so letter A and the lesson check. You have 2x squared plus 11x plus 12. So that factors as x plus 4 to x plus 3. You should have noticed that your magic x gave you 8 and 3. You factored by grouping and got your x plus 4 to x plus 3. Letter B. We have 4x squared plus 7x plus 3. So magic x gave middle terms to be 4 and 3. So then you find your GCFs, and we get 4x plus 3, x plus 1. Now again, if you flip-flopped your 3 and your 4 and your magic x, your GCFs might just be the reverse of mine, and ultimately you will get down to the same answer. You have to also remember that multiplication is commutative. So if you flip your binomials, then they are going to still get you down to that same answer. Okay, letter C. We have 2x squared minus 7x plus 6. You have 2x squared minus 4x minus 3x plus 6. And that gets you down to 2x minus 3, x minus 2. Once again, you'll notice that these were both negative because I had a negative and a positive. So we have 3 different case types for factoring. So your homework is that very next page, and that will finish up your packet. It also means that on Monday, I will have you turn in the a equals 1 and a greater than 1. So you can go ahead and use like the next 10 minutes that we have left of class to start on those homework problems. I am back here if you have any questions.